Hello everyone, hope you all are doing well. So now we will start our new chapter, that is thermochemistry. Talking about thermochemistry. Thermochemistry, it is a branch of chemistry which deals with the study of energy transfer as a heat during chemical reaction. It's called thermochemistry. From the name we are understanding the word thermochemistry. Like here is written that study of energy, we are studying energy over here with respect of heat, means with the transfer of heat during the chemical reaction. Two things in thermochemistry, one is energy and second is heat with the transformation during the chemical reaction. Let's move further. Here we are having thermodynamic. Thermodynamic means heat motion or heat movement. Like it is the branch of physics which deals with the study of transformation of heat, means from where heat can transfer work and other form of energy. Like not, it does not just a heat, that's the transformation we are doing any work, another form of energy. It's also called thermodynamic. Actually, it is a branch of physics in which we are having heat motion or heat movement. After that, there are some main points of thermochemistry and thermodynamics. That is, it predicts the feasibility of chemical reaction. Like it's just predicting the feasibility if there is any chemical reaction, so it's feasible or not. So it's predicting that feasibility of chemical reaction. There will be not any feasibility of chemical reaction. After the second point is it predict extent to which reaction can occur. Like it also extend the reaction, means it's not predict in that one to extend the chemical reaction that will be occur over here. Okay, and it's also tell the states of matter. It will, we will discuss this in next topic. Like it will also tell us the state of matter, that which state of matter it is. After we having limitations, that it could not tell the rate of reaction. It does not tell us the rate of reaction. Rate of reaction will is telling in the previous topic, that was a concentration, order of reaction. And next, that it's not applicable in the microscopic level. Like microscopic means very small amount, like we are having chemical reaction in very small amount, so it's microscopic level. But we will discuss over here macroscopic, like the bigger one, not a smaller one. Okay, in now here we are having system. It's a part of universe. System is a part of universe in which observation or investigation can occur. Like in universe is made up of two things. One is system, second is surrounding, is equal to universe. Talking about surrounding means that except system, remaining part of the universe is called surrounding. We will also discuss in diagram it down, that like except system we are removing the system part and just surrounding is remaining in a universe, that's called surrounding. Like in a boundary, like to separate the system to surrounding. Like if we are having one school, in school we have to separate the class, so we'll make boundaries over here. Like there are different classes, 1 2 3 4 5, so it's separated from this college boundary to make another boundary to make surrounding. After that, it may be real or imaginary, rigid or flexible. Like it does not depend that it's real or it's imaginary. Like in college we are having college. Okay, now it's a planned college, we are saying that this one portion is for playing, this one portion is for assembly. We're making imaginations that from this boundary is for assembly, this boundary is for sport, this boundary is for admin office. Okay, but in real it does not. So same here in diagram it gives that we are having one container. This container is a boundary. Okay, and inside that we are having this dot, that is our system, that is our system. Okay, and in system, and this is the surrounding, like outer part of its, all outer part of it's called surrounding. Okay, and in this one container, is there is just a real part or imaginary part, or both real or imaginary? So this is my question. Write your answer in comment that this is, in this one container there is real part and imaginary part both, or just there's a real part. So now you have to pause the video and you have to comment. And now I am answering this question. Here are the both parts. Like container. This container is real. Okay. So this is our real part. But there are just dots or just system till here. This all is called surrounding because it's empty. So it means this is our imagination. This part is our imaginary part. So it means in this one container we are having both real part and imaginary part. Okay, real part and imaginary part both. Now after that we are having types of system. Like we are having three types of system on the basis of its mass and its energy. Okay, first of all we are having open system. What is open system? Basically open system is a system in which mass and energy both can transfer. Like we are cooking over here, or like we are cooking in a kitchen, this is a pan. Okay, we are giving its heat, we are giving a heat to its. Okay, so this is energy, and we are adding the ingredients from here. And what this is mass. The mass is also transferring, and it's also getting energy as a form of heat. So this system is called open system. Which system? Open system. Now let's move further. After open system we are having another system that is called closed system. In closed system, in which mass does not transfer but energy can transfer. How? Let's take an example of cooker. We are having cooker in a kitchen. Like we are having a cooker over here. This is a cooker. Now at this cooker we are giving it heat. This is a closed cooker. Like this is the top of the cooker and it's closed. We add the material over here. Now we are giving it heat. Now what energy is transferring, but we cannot add mass because it's a closed system. So in which mass does not, but heat or energy can transfer. So that's called the closed system. So this is an example of closed system. Cooker is an example of closed system. Okay. After that, talking about third system, that is called isolated system. This is a system in which neither mass and nor energy can transfer. Both cannot transfer. An example of that is thermoflask. What is thermoflask? You know very well that the thermoflask is a stainless steel water bottles. Nowadays we are having digital water bottles or steel water bottles, or you can take a example of tea thermos. Like inside that we are adding the mass, and there is a capability to maintain out the energy. Means then we are closing it, like we add the mass, we put the tea over here and we close that. Now we cannot add mass over there, and we cannot give energy. Means it's not transferring us energy, the energy is not coming out as a form of heat. Okay, and we are unable to give energy from inside. So this system is called isolated system. Okay, so this is the today's topic. This was the today's topic that we have done. Thermochemistry, thermodynamic, their main points, limitation, system, surrounding and boundary, and types of system. That are three: open system, closed system, and isolated system. Hope you understand the starting of this lecture. Now we will move further with new topic.